Anyway, I think Allan is now ready. Over to you.
So good morning to everyone. Today, I would just like to introduce you to OBIA. So we shall just have a glimpse at what OBIA is, and maybe in case you want to progress further with OBIA, there is a folder that I'm going to leave with Professor Anton. It has already worked out examples, so you can be able to follow the tutorial. For example, how do you perform the classification using OBIA, and then also how do you combine OBIA data with LiDAR data, things like that. So I already have some guided tour examples that you can be able to look at, and they are step by step. I'll be able to pass them on to Dr. Anton. So OBIA is basically object-based image analysis, and I could say it's like a brother to per pixel classification that we've been doing. So in remote sensing, there's of course a lot of progress over the last the many years. So we've had, of course, an improvement in resolution as far as data is concerned, and then the availability, and then also there's a lot of public awareness. People have bought into the technology, and of course, most of the applications basically rely on basic image processing concepts that were developed many years ago, as far as the 70s or even the 50s. So what happens is that currently, when you want to do classification, there is what we call per pixel classification. You know very well about your pixel, their values, and then based on the the pixel value and the number of bands, so in that feature space, you can be able to do some kind of statistical calculations, or maybe apply some kinds of algorithms and be able to classify your image. So there's another school of thought that thinks that maybe these guys who are using per pixel classification miss out some. So they think that they miss out spatial concepts. So that's what that school of thought basically thinks. And they say, especially for high resolution images, very likely that maybe neighboring pixels, clear feature maybe belong to the same land cover, or maybe they belong to the same land cover as the pixel under consideration. Therefore, they believe that if you're doing the classification, you should be able to group things that are related to each other. You group them together. Be able to do that, they have created an algorithm that basically creates objects. So in other words, it looks through the image and then gets homogeneous areas or areas that look the same and groups them together first and creates an object. And now, of course, we can be able to classify these objects, and then can be able to also add more expert knowledge to these objects, rather than just doing a sample-based classification done in per pixel classification. So the ultimate goal of remote sensing, like we already have learned, this one I'm very sure that you've learned it. The whole big deal is just because you want to be able to quantify and describe surface patterns, that you can be able to contribute to an understanding of the underlying phenomena and process. So that's why basically you struggle to do remote sensing, and you have these images and you are classifying them and get data out of them. Now, the interesting thing is that this remote sensing data feeds into GIS. This school of thought, basically, the people who think about the proponents of OBIA, they think that if it's going to feed into a GIS, therefore it should also subscribe to the concepts in a GIS. So for example, in a GIS, we look at things as though they are features or objects. So in our databases, we also have the concept of objects. So when this data is delineated, or when you're doing the classification, you should have these concepts already captured. The concepts of those topological relations, for example, they can offer a topological relation. Something is rather inside another, something is close to another, something is maybe intersecting, equal to, contains. So all these kinds of topological relations be also incorporated in the image classification. That's what the people who think of OBIA should be using also. So that's basically one of their issues. And the remote sensing that's being done with per pixel classification doesn't incorporate the database concepts. Yet the data is going to be stored, rather it doesn't incorporate these databases or GIS, yet it's going to be stored in that kind of environment. So that's one of their points of contact. Of course, some of you may be be there thinking, what are these topological relations? But I'll just give you an example. You look at a road, for example, Sample Okagwa Road. The road moves towards the Gaddafi Mosque, and then there is Makere Hill Road. Those roads intersect somewhere around the playground of Makere here, or maybe around Chase Johnson. They intersect with each other. If you come with the same road going to where it says Sample Okagwa Road, you realize that once you reach the roundabout, the road passes under and it's not intersecting with another. So it's just passing under. So the GIS must be able to understand these kinds of concepts. Likewise, if you're doing remote sensing, you should be able to understand the remote sensing should be able to incorporate these kinds of concepts. So the context must be basically incorporated. So maybe reminding ourselves and contextualizing this OBIA. So whenever you're doing image processing, you have to acquire the data, and you correct for the data, and you do some kind of enhancement, and then you can be able to do the visual analysis, and then also now it's at this point of classification that you choose what type of classification method that you're going to use. Are you going to use per pixel, or you're going to use object-based image analysis? So of course, during the classification, you choose either supervised or unsupervised, so it's still the same. And then you have to choose the type of classification that you're going to use, and that's basically per pixel or OBIA. And then, of course, at the end, with all of them, you have to do accuracy assessment, just like you've been taught in your class. So this, with OBIA, you choose whether to use OBIA or per pixel based on many reasons. One of them can be your expertise, another one can be your school of thought, another one can be the kind of data that you have. OBIA has been proved to work best for very, very high resolution imagery, and maybe for low resolution imagery, maybe per pixel could be very helpful. So you choose what method to use depending on the data that you have, pool of thoughts that you subscribe to, or maybe your expertise. So with the guiding question for this OBIA class, so as OBIA guys think, why is it that remote sensing or digital image processing is still much focused on statistical analysis of single pixels rather than the spatial patterns they build up? So they think that maybe we should think about, rather look at the other spatial patterns rather than the simple pixels because of the context. Maybe you're shown a small part of the leopard skin and they ask you what those patterns are. You may say maybe part of maybe a very big cloth or something like that. So without the context, you cannot be able to make up, rather you cannot be able, you lose some other picture or some other information. So you need to have all this context. That's what basically OBIA wants us to have, so that you can have all these spatial patterns and the context in play as you're doing your classification. So with OBIA, the proponents think that there are many central concepts in geography that have been escaped or that have been left out as far as image processing is concerned. For example, there are spatial relations, the topological relations I was talking about, things like distance, things like connectivity, directional characteristics, spatial patterns, and then also the fact that you can be able to work at multiple scales, or maybe you can be able to work at multiple hierarchies. So they think that these concepts are left out. So for example, when you look outside, maybe outside the window and you look out there, interestingly, the eye tends to see things at multiple scales. When things are near, sees it as very big, and then once it's far away, it sees it as very small. So there are those kinds of scales at which you can be able to see the landscape. And so when you're doing the classification, you can be able to incorporate this kind of information, and maybe the software should be able to behave like your eyes do behave, so that you can be able to delineate this kind of information. So they think that these kinds of concepts are not available in the current per pixel class. So the per pixel classification, it's not that it's bad, it's actually a good method of doing the classification, but rather for a particular kind of data, maybe it may not be the best. That's what they are proposed this kind of OBIA. So per pixel classification, basically what happens in per pixel classification is that you have pixel values to a region, rather it's basically assigns pixel values to a region in a multi-dimensional space. So you get these pixels, and then you can be able to, in that feature space, you can be able to assign them to an information class. So the feature space basically is built by the n number of bands. So you have the different bands, and of course, for each band, you have basically the spectral information. But then they don't look at when you look at this feature space, it's not physical, so it doesn't look at space. And in this case, what happens that you only look at the reflectance values, and these reflectance values, once they are played around with, you can be able to merge them together and create information class, correlate them to information classes. So in other words, you only use the spectral behavior to be able to do some classes. So it is thought that this is half of the story, because you neglect so many other spatial characteristics of features to be addressed. For example, the neighborhood, or the shape, or the form. When you're doing the classification, you can be able to incorporate this, for example, in OBIA. So here is just an example. When you look at per pixel classification, you only look at the spectral reflectance in N-band, maybe the texture, and then you can be able to do your classification. But you don't look at things like form, the shape, neighborhood. If, for example, you had a park here, by looking at this neighborhood, then it could tell you that this is actually a park. The context and the levels, or the scale levels, you don't look at them. You only look at the color and the texture. So with OBIA, the aim is basically to represent complex scene in such a way that image reality is best understood and extracted, conveyed to users the way it's supposed to be conveyed. In other words, the benchmark of OBIA is that our visual sense of the environment is easy to share. So we can be able to talk about the environment, because human beings, we are very brilliant. We are very brilliant more than computers. For us, we can be able to share our visual aspect. Just I was talking to you, I will tell you here we have maybe this kind of landscape and something like that. But then it's very hard for us to just describe them in words. If I was just give you a visual bit, maybe a picture, maybe you can be able to look at, and you have this kind of sense share. But then it's very difficult for us to express them in words, or even rules, or even basically in a computer environment. So it's very hard for us to be able to put them in a computer environment and be able to interpret them just like how we interpret them in our heads or our senses. So OBIA basically utilizes concepts from spatial thinking and influenced by cognitive psychology. When you do this classification, you realize that at first it becomes a little bit tricky, because you don't seem not only to use rather the pixel values, but there are other factors that you consider. And maybe if I'm given another time, I could be able to express these kinds of things. But then for you just to realize, when you, for example, when you use per pixel classification and you try to classify out, maybe try to do classification, what per pixel classification will tell you is that this is water. Then they tell you that maybe this is vegetation or particular kinds of land covers. Also tell you that this is water here, and to tell you maybe green is the maybe grassland or something like that. Maybe red is forested. So it will just tell you that kind of thing. But when you use object-based image analysis, you can be able to infer from the form or the shape that this is a river and this may be a lake or something else. So because of this form, we're able to go further from water. We can be able to infer and say that this is a river. And because this is grassland and is surrounded maybe by the forested area, we are able to go beyond saying that this is grassland to say that maybe this is a park, or maybe if this was built up area, we're able, and then we see this is grassland, we're able to say that maybe this is a municipal park, something like that. So in other words, we can be able to use context, neighborhood, and then we're able to find, we're able to find a particular kind of land use. So object-based image analysis is very good for land use map. So it can go beyond the land cover mapping, and then you're able to also map land use. For example, if you had a recreational area and maybe you have agriculture there, then rather you had grassland, you had agriculture there, you had recreational. It's very easy for OBIA to use rule sets and also expert knowledge, the knowledge about the area that the expert has, be able to do that classification and delineate those land use. Or maybe the other could be, you had a land cover map, says maybe these are the land cover class. It's very possible for you, if that area resides within water, for you to use the neighborhood characteristics and say, wherever we have a neighborhood of 1 or water. So in other words, you have water circling neighboring the whole land. That's an island, not rather only just about the land cover, but then it's an island that has this kind of land cover. So you can be able to delineate those kinds of complex land uses and that you never do using per pixel. So we can have, we usually with the per pixel classification, we have the pixelized by their spectral behavior in the n-dimensional space or feature space. And basically that can be done with spectral data, be able to create your color composite or false color composite. You can do it with quick path data, you can do it with Landsat data. But if we are to use image-based analysis, we can be able to create images instead of using pixels, rather objects instead of using pixels. So for object-based image analysis, the smallest unit is an object. Well, for per pixel classification, the smallest unit is it. And we can be able to perform our normal sample-based classification, just like you've been doing with your per pixel. And just because we're experts, we can be able to add, you have your expert knowledge, you know the area better maybe. So the more the knowledge that you have, you can be able to better classify an area. So we can be able to add so many other characteristics, for example, the neighborhood characteristics, some other geometrical characteristics, hierarchy characteristics. Then we're able to basically be able to classify. So whenever we are looking at per pixel classification, I already told you that the smallest, or the building block is basically. But if we're using object-based image analysis, building block is an object. But you note in this picture here, if you look at this object here, I don't know that you're seeing my mouse, level 0, you realize that this object has neighbor. At the same time, this object has its super object. At the same time, this object also has been divided into other small sub or child. So OBIA should be able to understand these kinds of hierarchies. So you can start with this big object, and then you have basically a hierarchy of this small object, and then you define the neighborhood characteristic for this object, and then also you can be able to define the sub or maybe the child classes. That's a very interesting thing with OBIA that you can't just do with per pixel classification. Because with per pixel classification, you look at it from one level. So with OBIA, you can be able to introduce multiple levels. For example, the first time, you have land cover. The next time you drill down, then you get this land cover, for example, recreational or maybe forested. Then you're able to use your neighborhood characteristics. This is an island. Then you drill down to the this island with the forested. Then you can be able to even create minor land uses out of it, whatever this forest is being used for. So that's very interesting with OBIA. That basically is very powerful. Once again, within the software, there are particular kinds of features that are available. So for example, we have the layer values, so we can be able to get the pixel values, and then these pixel values for each object that is created. I'm just going to show you this thing practically, because when I talk about these things, it looks like as though we talk about so many things, not practical, but it's practical. So I'm going to show it to you. So basically what happens is that in each object, they get all these pixels, and then they calculate the mean. You can be able to calculate the mean, the standard deviation, and so many other statistics. And then you can use this for sample-based classification, just like you're doing. Now, these objects basically have characteristics. They have characteristics like color, shape. There are some landscape metrics that are used to calculate the shape characteristics, and then also the texture and also the hierarchy. So we can be able geometrical properties like the size, the shape, like I've already showed you, and then also the texture properties like the layer text values. So some of them we get the mean, the standard deviation. All depends on what you want to calculate. And then also we can be able to have hierarchy incorporated as far as the classification is concerned. So you can be able to define super object, sub object. Then also we can classify this object in relation to the neighbors, just like we saw in the previous slide here. You can be able to classify. So those are some of the things that you can be able to do, and you can also be able to classify as far as membership is concerned in relation basically So here is the concept of hierarchy. You have basically the entire image. In this entire image, you have basically particular kinds of classes. Of course, if you looked at it as one single image, it looks like, you have one big block, but then you can be able to break it down into different, for example, classes, and then even these same classes can be broken down to finer one until you get to the pixel level. So in other words, it's very possible for us to break down this image into objects that are meaningful in a hierarchy, rather than a hierarchy that's meaningful. Now, there's one other interesting thing about OBIA. OBIA allows us to be able to incorporate knowledge graphs. So we can be able to have these kinds of knowledge graphs. For example, say the pond is part of a golf course, and the pond is more specific specific, rather has what I need. Maybe you have the water having a particular kind of spectral value, and maybe a pond has a particular kind of size. So when you do the classification, actually what happens that you only classify for what you see water in the image if you're using per pixel based on the spectral value. But then you can go ahead based on size, say that maybe this is a pond, based on also where it's located. If it's located in a particular recreational area, you can say, oh, I think this is the golf course, because it's a golf course that always has ponds. So you can be able to have this kind of knowledge represented in the classification. So I was talking about the hierarchy. So for example, we have the child and the superclasses. You can be able to represent them, and then you can be able to group them semantically. So group them according to similarity, So for example, have your bright vegetation, or maybe it's grassland, and then you can say, oh, it's a meadow, or maybe it's a football field. So you can be able to separate it into those different subclasses, and then each of these classes will be able to inherit characteristics of this bright vegetation, but can also be able to have more. And then also it's very possible to have, for example, bigger urban areas separated into built-up football field, and all these also can be put in classes that are related to each other, classes whereby they are related to each other. So how does OBIA work? How do we do OBIA? What happens that you have an image in the beginning. Like I told you, most of these images are high resolution. Can also be applied on medium resolution, but usually it's the high resolution image. So you have this image, and you get it into the software. First of all, with this image data, you'll have also some other contextual information. You know the place better, or as an expert, that certain things be able to see. And your role is not only to use the software and do the classification. Your role is also to transfer this knowledge that you have into the classification. The first step is basically to do image segmentation, getting this image, and then you have similar areas being grouped into common objects. Now, the size of these objects is always a very big question. So the objects in this case become the primitives, or become the building block, and then you can be able to select your training sites on these objects. You say, for example, this object, I think this is a built-up area, or this object is maybe water, or something like that. And then you do your initial class. You use typical methods that you use also in here. The difference is that you're starting with objects, not just methods. And then all you do is you do some classification, and you can use methods, for example, nearest. That's one of the methods that's used. Now you'll get some result. If you're not convinced about the result, then you have to get back to the segmentation. It could be that actually the sizes of those segments that you're creating, all those sizes basically may be small or bigger. So if they were bigger, you decrease them, and then you do the classification again. And then you see the quality of the classification that comes out. Now, so the segmentation and classification, basically at this point in time, you have an iterative kind of process. You go to classification from segmentation, and from classification, you can go back to segmentation depending on the quality that you have gotten out of your classification. Now, once you've gotten that quality out from the sample-based classification, you need to do a rule-based classification. So you need to specify rule sets. Now, these rule sets will have knowledge that you know about this scene or about that area, knowledge about the neighborhood, about the hierarchy, about the context form, the shape. So you can be able to incorporate this kind of knowledge also about so you can be able to incorporate this kind of knowledge using rules. So those, you incorporate them on an already classified or sample-based classification. So you first do the sample-based classification. This is synonymous to the classification you do in per pixel image analysis. And then after that, you can be able to incorporate these kinds of rule sets, be able to even better extract more information out of the image. And then once you have your final classification, you can be able to convert this classification into polygons, points, lines, or even raster. So that's basically the workflow of OBIA, or maybe object-based image analysis. Start with the image, do the initial segmentation, get objects, do the classification, and then you start thinking, or maybe looking at the result. Is this result okay? If it's not okay, or if it doesn't pass your accuracy assessment, you continue doing the iteration until you basically get a better result. Then you can apply your rules and then be able to better classify the image. So in other words, there's a step further of defining rules in OBIA. So there are two pillars of OBIA. The first one is image segmentation. I told you that you have to do the segmentation this stage so that you can get similar objects in similar, or rather a similar thing. You can be able, all homogeneous areas can be put in rather than one object. And then image classification. So of course we start with image classification, but you cannot just say that from image classification you just go to, rather we start with image segmentation, but you cannot just say that from image segmentation. It's an iterative process. So this is what happens during image classification. So you basically delineate units, you create units in an image based on homogeneity. And of course, at the same time, you have to look at also the spatial. The issue with this kind of rather segmentation is that you will never be sure, or you're never sure the sizes of this object, what is the best size of this object. So providing images, rather image objects that match the scale of operation is a very big challenge. Of course, there is a small tool called estimated scale parameter in eCognition that allows us to be able to estimate the scale, the appropriate scale for which you can be able to delineate this image. It's still a challenge. There are different methods that are used for segmentation. I'm going to show them to you so that you can be able to go and read about them, and then also you'll have also some paper be able to explain all these kinds of concepts so that you can be able to better understand OBIA beyond this lecture. We have methods that are histogram based, and they basically use the spectral characteristics to be able to delineate or to be able to segment those objects, and they ignore the spatial dimension. We also have edge-based methods, which basically search for edges between homogeneous areas. So if you have two classes, some edge between them, so it searches for those kinds of edges. We also have region-based methods, basically deliver regions differentiated into region growth. So it uses the region growth algorithm to be able to create this segment. We also have the chessboard. So what it does, just gets the area, divides it into squares, just like it. We also have the watershed segmentation. What it does, it gets the spectral values and looks at them as though they're height values, and then can be able to delineate a watershed. And that watershed is basically an object. And then we have large-scale segmentation. This tries to mimic how a human being looks at, for example, the landscape out. So when we look outside there, we see things at different scales. And so the software tries to mimic that kind of segmentation. It's the most used actually kind of segmentation. And then we have the chord tree segmentation. For you have done indices in databases. You know that the chord tree is some kind of algorithm that keeps on subdividing, or maybe it uses a strategy of it keeps on subdividing to the smaller units. So that's basically. So I'll show you how these different methods work. Be able to go and read about them. So with the second pillar is basically image classification. So with image classification, you classify image objects, not pixels, but image objects. And you can also, rather, you exploit area, shape, form, be able to do the classification. When you classify without using this parameter, what you're doing is basically a sample-based kind of classification on the image object. But then for you to make the classification better, get rid of those misclassifications, or maybe to be able to delineate even higher end kind of classes, or maybe then you should be able to utilize these kinds of characteristics like shape, form. So of course, in this case, we also use an algorithm to be able to the classification, the sample-based classification. So we have two kinds of the classification. We have two kinds of classification. So we have the sample-based and the rule-based. We first do the sample-based, and then we progress to the rule-based. But with the sample-based, we use similar algorithms, just like we do in pixel classification. So of course, just like we showed you in the workflow, the process rather between segmentation to classification is iterative. You have to, you create a segmentation, but if the segmentation doesn't work for you, then you go back to the segmentation algorithm, and then change the shape characteristics, the form, and you try to enhance them, and then you do the classification again until when the intended results are achieved. So when I talk about the enhancement, what we are meaning is that you just have to go to the shape characteristics and change them. So I'm just going to show you. And then, of course, once you've done your sample-based classification, you can now apply things like neighborhood and other spatial relations you need to apply. Now, of course, we saw in the beginning of the lecture that the proponents of this OBIA, they think that these concepts are left out. These are the spatial relationships that basically a database conforms to. But then they think, why is it that we do per pixel classification and then we leave them out, and yet we still get this information and put it into the same database, which conforms to these relations that for us we seem to neglect? So that's basically their kind of question. So finally, your desired object classes can be described basically, they can be described easily, and of course you must have some kind of domain expert knowledge. So if you don't have this knowledge about the area, or you don't have the domain knowledge, then it becomes very hard for you to be able to create a rule-based classification. So I just imagine they just give you an image of a certain area, and you've never been there, you know nothing about it. The best you can do when they tell you these are the training sites, the best you can do is just classify it using the sample-based. You may not have the knowledge about that area. And also the quality of the classification that you'll always do, it depends, or create, will always depend on your expertise as an expert. So like I told you, that bit of resegmenting and then reclassifying can be done basically in a stepwise way, but also once you've done the classification, always apply rule sets and reapply rule sets until you get the desired. So you'll take your time and look through this classification. So for example, we have the hierarchical classification. We also have methods like the fuzzy logic classification approaches. So you can be able to read through and then be able to see the different kinds of methods. So maybe if we're given another time, we can be able to look at sample-based and rule-based classification in detail. The goal for this lecture was just to introduce you OBIA and most likely show you the workflow and when basically we need OBIA and at what stage to use OBIA. So I would like to take you to the software. So of course there are different software that can be able to do OBIA. One of them is recognition. So this is one of those software that can. So I was telling you that the first step that we do, of course, you can see that this is a high resolution image. And with this image, it's very possible for us to start looking at it in terms of, we can start, for example, creating you can imagine what is happening here. It's very possible to create a false color composite or true color composite with this. So these are four bands. We have the visible portion, blue, green, red, and then we have also the near infrared. It's very possible for us to create a false color composite, as you can see. All areas that are red, the vegetation, and it's very possible for us to go ahead and we can be able to delineate these. We can first of all delineate them using feature extraction. So we can just maybe say we create near infrared and then actually delineate them using a customized kind of algorithm. Let me first classify. You see that there are different methods of there are different methods of segmentation. For example, if we use the chessboard, what happens? So we can maybe create the object size as 10. You see it divides the area to a chess kind of area. It's also very possible for you to change and say, okay, if we use Kodu tree, what happens? So you say it creates basically like a Kodu tree, divides the areas into objects that are a Kodu tree. Now, notice that whenever I click here, something here happens. So you can be able to get these characteristic layer values. You can be able to say, I need, whenever you click here to bring you the mean values for the pixel value, rather the pixel, layer 1 and layer 2 and layer 3 and layer 4. So these are the values. You can also, we can use another classification method. Now, these methods are not based like the chessboard. It's not based, it doesn't consider the spatial, it doesn't consider basically the spatial concepts or the space. It just basically looks at these two actually do the segmentation based on the pixel value. Now we have also the contrast split. Try this and see what happens. So this is what it's doing. So it's up to you to go and look at these methods and read about them, but at least I've showed you what basically how the result looks like. So we have multi-resolution. This is the most common one. Now, I was telling you with multi-resolution, you can define the level. For example, this is level 1, and you can define the scale parameter and say, need my objects to be maybe, define the shape, the compactness, and then you execute. So you realize that this basically classifies objects just like the eye would classify them, rather segment them, segments the object just like the eye would look at them in the. Now this is basically one way of doing it. Now I was telling you, you do the classification, then you're able to find out things like if you see the classification is not good, then you can come back to here and edit these things like shape. That's the enhancement I was talking about. Or you can say, let me make my scale parameter. So the problem we're saying about the scale parameter, it's not easy to determine what is the best scale parameter. Not very easy. Maybe this is too small. Maybe I should make it 50 and see what happens. So we can do different kinds of classifications here. One of them can just be to extract just a feature. Another one can be basically do the normal sample-based classification, and later on we can be able to do. So for example, I could do a feature classification where I say NDVI, and then say maybe our NDVI is equal, I don't know that I'm right, but can be able to create your formula here, and then so I'm counting. When you tell me the formula, it's supposed to be an arithmetic. Yeah, it's an arithmetical algorithm. If we click here, it will tell us the value of NDVI. So you may say that maybe you want something where the value of NDVI is maybe 5.1 or something like that. So you can go ahead and do the classification. So you can basically assign classes. I have to create a new class here. So I'm just trying to do the simple things so that maybe the next time when we meet and we're doing practicals, we can be able to do more interesting things. So this is one of the methods that you can use, but you can use other methods, for example, the hierarchical kind of classification. So you can create your threshold condition. So that class will be called vegetation. Your threshold condition can be NDVI. So let us first try this. Seems not have given us what we want. So maybe we created, let me check the NDVI value. I think I've done it the other way around. It's supposed to be this way around. So I just want to look at if I can look through the tutorial and see the value I have to put, but maybe we are a little bit faster. So I have a tutorial here that you can be able to follow. I just need to delete this. So this classification is not supposed to be there. I don't know why it's persisting, but I'll just add. So according to our small tutorial here that I'll share with you, station, and then you say level is maybe, it's -25. That was for water. So maybe let me restart it afresh so that you can be able to see what I was talking about, and could be a problem of the software. So we use the rule set mode. Then you have to bring in the image by opening a new project. I get my image here. So you label bands, that's if you do wish, and then you have this already. The first step is to do the segmentation. So we are going to do the segmentation, and in this case, they're using a scale parameter of 200. But you can choose your own scale parameter, no problem. If you choose 10, of course, something will happen. But if you choose 200, you also see that it will be different from what we had before. So you see, before we had 10 or even 30, you see what happened. You get more objects. So you can change this, for example, the shape, and then you'll have something like this. The other time I did layer mixing, and I was doing it from here. So very possible for you to have your first color composite just like this. They're telling us we just create two classes. One of them is another one is water. So this is the basic classification, but you can do so many other classifications. We can first also, I've not done the typical sample-based classification. Reason being that we need more time. I just want to do a simple classification so that you can be able to see how it works. Notice that here the smallest unit here is click on either of these, you get the mean value for the object. From our small tutorial, they are telling us that we can be able to create our own custom. We can create our custom logarithm, which is basically NDVI. So we just go to our calculator and do the same calculation that we did before. So if you click, you're going to see the NDVI value. So what they are saying is that we can be able to do our classifications based on these NDVI values, for example, and the object. So that's one form of classification that you can do, the feature extraction. But then also you can extract all the features if you want. So you can invoke a small rule set, and then you're able to extract, for example, values based on NDV. In our tutorial, we can be able to use of course, we've used the multi-resolution segmentation to get to this point. We can be able to do the classification create our using the assign class. The level that we're using is still this. This is the only level that we have. I never labeled it. I just left it new label. So class filter is this. So we look for the classification. If you want to do the classification, you see all areas that are vegetation have been classified with an NDVI value of greater than 0.25 have been classified as vegetation according to our rule set that we've created. So these are called rule sets. We can create another rule set. Then we say maybe that's the other rule set of the water. Anything that has a threshold negative 0.15, anything that has a value less than that, we call it water. And then if we do the execution, it will then classify out water. So that's one result that we have. So this is a bot, it's moving around. So we can also try to get classify others using other rule sets. It's also very possible for us to use the normal typical method, whereby we have to first define we have to define basically our samples first. So if we have our object, it's possible for us to come to classify and we describe our samples. We say, for example, select here water. You come and say, I think I can use this, and then you come and say, or maybe let me come and say, this is water, this is water. Then you come to this and say, this is vegetation. You can create actually the third class here. Then we say, oh, this is built up. So depends on the way you select your classes. Once you're done with that, then you can be able to get all classes, use basically the nearest neighbor, and you edit your feature class. So you can say, I need this, be in my feature class, all these bands, and then you can come to your nearest neighbor and you apply your nearest neighbor to class. Then you say, okay, if you come here to you can create a new rule set, you do your hierarchical classification, and should be able to normally and then be able to get your classification and see that has been classified accordingly. So it's very possible for you to create this is basically the typical classification, sample-based classification that you do. Typically, you just do step number 1 and step number 4 only, so that you can be able to classify your image. But you can also be able to add rule sets. For example, use NDVI to extract out vegetation so that you don't have misclassifications. You can also, you see this board here, we can apply some rules and say, for example, anything that's surrounded by water by that extent cannot be built up area, because you know that this place is just a river and maybe there's no island. So you just say anything that's surrounded by water to this, maybe to 0.9. Basically, these are shape characteristics, and these shape characteristics are gotten from. So you can be able to get the shape index. Each and every time you click here, you'll see the shape characteristics. So you can say, for example, if the shape index here is maybe the roundness or the neighborhood, you can also look at neighborhood. You can create all these kinds of things. So you can be able to look at them and be able to say, okay, maybe the neighborhood is this. Based on these characteristics, you're able to define new rule sets that delineate something that you know it, but of course the software doesn't know. For you, you have to tell the software incorporate this kind of knowledge that you know this place, the built up area, so you can be able to incorporate it here. So that's what basically OBIA allows us to be able to do. We can be able to incorporate these relationships, and then also more than also the as well as the shape characteristics, more than just having these layer, rather the mean values, the spectral values. These are just basically spectral values. But we can be able to add the geometry, the neighborhood, so many others, the texture, the classification, and we're able to get much more quality. So I beg to stop here. In case you're really interested in OBIA, you just have to follow the tutorial that I'll give you, and then you can be able to, I'll give it to Professor Anthony so that you can be able to follow up and be able to do the OBIA yourself. Then as well, rather for the segmentation methods, you just need to come to this and be able to see the different methods. Then you can explain what they do, why you should use each of them. Per pixel classification, the smallest unit is basically a pixel, and it uses texture and spectral values in a multi-dimensional feature space. So in other words, basically where you have your bands and the spectral values in that kind of feature space, and all you do is basically sample. With OBIA, what happens is that our smallest unit is basically, we delineate features that are similar. So homogeneous areas that are similar, we delineate them and put them in the same pixel, rather same polygon. And then this is the smallest unit for our class. We say the problem here is achieving the best scale parameter. Then later on, we classify, and then we get a result. If we are not contented with that result, we go back to this segmentation algorithm. We can be able to change the scale parameter, or they change the shape, characteristics, or enhance the compactness, or even the layer weight. Each one should be more important than the other. And then also we can be able to create multiple scale levels if we do one. Then we execute, then we're able to get another kind of segmentation, and then we use it until we get the best result. We don't stop actually changing this segmentation result. But then we said, as an individual, you always have many more, you always have much more knowledge about the area than maybe someone who has never visited it, or maybe someone who's not. So based on all those kinds of qualities, you can be able to create rules and be able to delineate features that would not be possible with Java. So in that way, we can be able to incorporate characteristics. For example, the spatial characteristics like neighborhood, relations to super objects, relations to different classifications, relations to scene features, and also things to do with the texture and the spectral values. And we can also be able to create our own loop. So that's it about OBIA. In case you're interested, feel free to get the folder from Prof. I'll give it to him one of these days, or maybe today. And you can be able to do this OBIA. It's very interesting. You'll find the images of different places, and maybe you could use. Thank you very much.
Thank you very much, Allan, and very illuminative lecture. Three keywords: image segmentation, image classification, rule set. If you're going to do OBIA, those are things you need to be conversant with. As you can see, the difference between this and what you have done for your assignment. Here we are classifying, the object, but of course it's building up on our previous knowledge. So it's good to have all these tools. You never know where in the world you'll be thrown, and you need an appreciation of these skills. As soon as I have the folder, I'll inform your class representative, and those who are interested will be able to get it from him or from me. So that is it from us. We have been a bit constrained because of COVID and the like, but hey, we have to live with this reality. But I hope that you have enjoyed your journey through remote sensing and seen how we can use all these tools for mapping. Please remember that these are tools that you will be able to use at one point or the other, maybe for your final year project or where you'll end up working. So that's it from me. I don't see any question, but I'll give anyone an opportunity to ask. Does anyone have any question? If not, I think, and I wish you the best in your exams. I will mention that everything that we have done is potentially coming. So that is it from me, and I wish you all the very best.